Hello, my name is Karol. Welcome to the Good Code channel. The problem we will tackle today is problem connected to binary trees, and we will try to find minimum depth of the binary tree. Okay, so first of all, what is binary tree? Binary tree is a data structure where parent can have up to 2 kids. Okay, so in this case, the top parent, the root, is node with a value with ID of 1, and it has 2 kids. Kid to the left has ID 2, kid to the right has ID 3, and so it goes on and goes on. Okay, and we want to search this tree to see what is the minimum length. So in our case, we want to find this element, okay, because in our case the depth is 3. So we will see if anything ends on the level number 1, then we will check all the elements on the level 2 to see if any of them is the finishing element. So if any of the elements has no kids, then we will move to level number 3 and see if any of these elements has no kids, and we will be succeed because element with the ID of 4 has no kids. And when it comes to searching trees, searching graphs, which are basically more or less the same, we have 2 algorithms to do it. We have depth first search, so we are going as deep as possible and searching and then tracking our way back. So in the case of depth first search, we will go 4, 3, 5, 7, 6, 8, but it really doesn't work for us. It will work, but it won't be the good solution. The better solution would be to use breadth first search. So we'll check 1, then we'll check 2, 3, then we'll go a level down, so 4, 5, 6, and while checking the conditions for 4, we'll see that it has no kids, so the tree minimal depth is 3. Okay, 1, 2, 3. Okay, so those are the 2 algorithms you should know if you are trying to create any solutions based on the tree and on the graphs. Okay, so that's the theory. Let's get down to coding. As always, I encourage you to try to solve this all by your own, and only after that check my solution. And as always, code will be available in the description underneath the video. Okay, so let's start. First of all, we need a easy tree node structure, and there it is. It has basically only the core items, so it has ID, it has left node, and it has right node. Nothing really much is needed in our case. This is our solution, so we will come back to it in a second. Okay, what interests us is the place where we are creating the tree. Okay, so this tree that gets created over here is this tree, so the one that we were talking about at the intro to this video. And what we want to do is to call a function find minimum depth and pass this tree as an argument. Okay, so I will put a breakpoint inside the function because this is where all the interesting stuff is happening, and basically that's it. Okay, we can press F5 and run it with a node. Okay, I will clear my console, and we are inside. Okay, and we are inside of our find minimum depth. We have passed the root node of our tree as a node, and we passed initial level, so level number 1. Okay, so we are creating a queue because when we are working with the breadth first search, the queue is the data structure that we want to use. So the queue at the beginning has 1 element. This element is of course an object. It has a node and it has a level. Okay, so what I want to do now is to call search function. Of course, search is a recurrent function, and it's going to call itself a bunch of times and and work with this queue that holds elements of our tree. Okay, so let's go inside the search function. Okay, I will add queue to the watch. We have a queue with one element. Let's see what the current node is. Pop, of course, takes the element out of the queue and returns it. And first of all, break condition. This break is going to work if the initial root is missing a left or right child. Because it does, it means that the value, okay, it means that the minimum depth of the tree will be 1. Okay, in our case it's not the case, so the break condition for our recurrent function is if the node we are currently working with is the last node. If so, please return the current level. Okay, is last node is pretty easy function. It takes a node and it checks two conditions. Basically, if node has nor left or right child, in that case it is the last node. Pretty easy. I simply extracted it just for readability. Okay, so my node isn't the last node because it has right and left child, because it's node with the value of the ID of 1, so this one. So we will continue down our path. Okay, so we are checking if the node has left child. We will unshift it to the queue, so basically add it. Okay, and if the node has a right child, we will also unshift it and add it, and in both cases we are increasing the value of level by 1. Okay, cool. So where we are right now, we will be at this level. We have two nodes, node with ID 3, so that one, and node with ID 2. So yeah, so that one. Okay, so just as we planned. Okay, cool. So we are calling the search function again. Again, we are popping a node. This time it is node with the ID of this time is a node, sorry, with ID of 2. It's not the last node because it has a left child with the ID of 4. Okay, so it's not the last node, and we are checking, does this node has a child on the left? It does. So the node was added, the node with the ID of 4. Okay, so at this point in our queue we have two nodes, node with the node with the ID of 4, so this one that is on the level number 3, and node with the ID of 3 that is on the level 2. Okay, so it wasn't the last child, elements to the queue were added, and we are on the search function again. Okay, again we are popping value from our queue, so the only node left now is the node with the value of 4 and the level 3. Okay, node that we are currently looking on is the node with the ID of 3, so this one, it isn't the last node because it has two kids, kid 5 and kid 6. Okay, so we are over here, we are adding elements to our queue. Cool. So at this point our queue has 3 elements, only the ones from the level 3, so 4, 5 and 6. Cool. We are calling the search again, so now we are checking this level. Okay, we have already checked this level and this level, yeah, so we are using breadth search, this and this. Okay, again let's pop element from our queue. It's not the break value for the main root. Okay, and now it will be the last element. Okay, because it has nor the left child or the right child. Okay, so we see now that in this case we are going to return number 3. Okay, we are checking left, right, cool. So we are going to return it, return it, return it, and again we are going up our call stack and we are at the first return. Okay, so let's hit play and we can see that indeed the value that got returned equals to 3. So first level, second level, third level, and at the third level we have an element that is the last one, okay, that has no kids. So that's that. It was our first encounter with breadth first search. I strongly encourage you to know this algorithm, know when to use it. And that's it from my part. If you enjoyed the video, please leave comment, like or subscribe. It really helps to spread the channel. Thank you very much and see ya.